Welcome, everybody. Okay, so we are going to learn our third and final graphing technique here. We're going to be looking at something called standard form. When we graph in standard form, we see standard form being different than slope-intercept form. So this is slope-intercept form. And you'll notice that in slope-intercept form, the equation is solved for y. It's y equals a number times x, that's the slope of the line, plus the y-intercept. And then we graphed it really simply. We started at the y-intercept, start at 0, whatever the value was for b. And then you move with the slope equal to the rise over the run. And we made sure that we wrote that as a fraction. So now we're here, and it's going to be in a different form. If you look down here, there's a number times x plus a number times y equals c. X and y are the variables. A, b, and c are what we call integers, or whole numbers, positive and negative. So we're going to learn what that is. So let's go back to the old notes that we had on the golden paper. If you take out your goldenrod paper notes, we practiced graphing in slope-intercept form. We did a really big graph of y equals 2x minus 4. We graphed some other equations, some with positive slopes. Y equals 2/3 x plus 4. We started at 0, 4. And the slope was 2/3. So we went up and right. And we did that with a little more difficult y-intercept number. Then we started looking at some negative sloping numbers here. The slope is negative 4. That could be written as negative 4 over positive 1 or positive 4 over negative 1. But we always started at the y-intercept, 0, 2. We did that a few times, and you were supposed to turn that in. Another one with negative slope. M here equals negative 1 over 4, or 1 over negative 4. And then you were supposed to start at 0, negative 8. And then we had a problem where it started to slightly get out of slope-intercept form. So these were both like that. You had to distribute first. You ended up with y plus 5 equals 1/4 x plus 6 over 4. Okay. Well, we could change that to y plus 5 equals 1/4 x plus 1.5, and then subtract 5 from both sides. And you get your y equals 1/4 x minus 3.5. And now you could graph it starting at 0, negative 3.5, and the slope was 1 over 4. So up and right. So you were expected to do all those, but then there was a final page, and you notice that, oh wow, when the equations are in standard form, you can rewrite the equation using the distributive property, combine like terms of inverse operations, or there's a better, easier method. Okay, so here we have what we call standard form. Got a little typo here, but standard form, ax plus by equals c. Anyway, standard form is going to be super easy to do, okay? We're just going to find 2 points. You're going to find what we call the x-intercept and the y-intercept. Okay, well, we know the y-intercept is when x is 0. This is when x equals 0. So what we do is we just start a little point here. We'll put a 0 in here. We'll find the point when x is 0. And then for the x-intercept, we'll do the other thing. That's when we'll make the y-coordinate. So we're just making one of the coordinates 0. So we could do either one. Let's do this one first. Let's make x 0. Okay, well, negative 6 times 0 plus 9y equals negative 54. This is 0, so this is gone. And now it's really simple. 9y equals negative 54. I can divide by 9, and I get y equals negative 6. So I have 1 point that I can graph already. 0, negative 6. And now I just need to find the other one. When y is 0, negative 6x plus 9 times 0 equals negative 54. That's gone completely. And I have negative 6x equals negative 54. If I divide by negative 6, I have two negatives as a positive. 54 divided by 6 is 9. So I have my second point, 9, 0. 2 points in this method is all you need, and you need some kind of a straight edge. Lay it down and connect your dots. And now you have your equation negative 6x plus 9y equals negative 54. That's an equals negative 54. So that's what you were doing on that's why I had you pause for the last page of that lesson. And now we're on to just looking at it in general here in standard form. We're going to do the same thing but with a simpler problem here. Okay, so first, is the equation in standard form? This equation is yes, in standard form. Y, it's not solved for y. Now we could rearrange it and put it in slope-intercept form, but this is an easier method. When x is 0, all you have to do then is just cover up the number because it's going to become 0. So when x is 0, y equals 10. Now this graph doesn't go up to 10, so I'm just going to raise it up a little bit. Go 8, 9, 10, keep it going. So 0, comma, 10, I'll put a dot there. And then the other one says, okay, well, what's it when y equals 0? So we'll just cover it up. Negative 2x equals 10. When that happens, you divide by negative 2. 10 divided by negative 2 is negative 5. And there you go, negative 5, 0. Let's label that point. And once you have 2 points using intercepts, you can draw your line. Nice dark line. And that's all there is to graphing using intercepts. Make sure you write the equation of the line on the line somewhere. This is the negative 2x plus y equals 10 line. Let's turn the page and see the next. All right, next example here. Is this equation in standard form? Okay, well, let's look. Standard form. ax plus by equals c. Okay, a, b, and c are all integers. 20 is an integer, 4 is an integer, and 8 is an integer. So we're good. All we have to do is make x 0 to find the y-intercept. We'll just cover it up. 4y equals 8, so y would have to equal 2, because 2 times 4 equals 8. And then we have 20x equals 8. Okay, well, let's do this one. 20x plus 4 times 0 equals 8. We cross that out. I just need to divide by 20. And I get x equals 4 over 10, 2 over 5. So it's a strange point, but that's okay. 2/5, comma 0. 2/5 is right here. I'll just go ahead and label this point 2/5, comma 0. And 0, 2 is here. It's a very steep line. And that's fine. Just nice and steep. And it's relatively quick and easy to do. That's graphing in standard form. You'd always want to go 20x plus 4y equals 8. What do you think this line would be in slope-intercept form? Let's practice and see if we could rearrange the equation into slope-intercept form. We do that by still using our methods we learned from Unit 2, 20x plus 4y equals 8. To get into slope-intercept form, I have to solve it for y. So I would subtract 20x from both sides. I'm not going to line those up because they're not alike terms. I get 4y equals negative 20x plus 8. And then I have to divide both sides by 4. I ended up with y equals negative 20 over 4x. And that reduces to negative 5x plus 8 divided by 4 is 2. So 0, 2 is the y-intercept, and then it's supposed to go down 5 and right 1. 1, 2, 3, 4, 5, right 1 it does. So you can still use and see the other way, but the other way is a lot more work. And here we have a little easy problem. The table shows the cost for clothing store, jeans and khakis. Okay, the total cost for Saturday's shipment is $1,800. And it's got this $15 per every jean, $20 for every khaki. X-intercept and the y-intercept, okay? So let's find out when the y-intercept is when x equals 0. The x-intercept is when y equals 0. So if we think of x as being jeans, what if you sold 0 jeans? How many khakis would that be? What if you sold 0 khakis? So the y is khakis, and the x is jeans. So we end up with, if I put 0 in there for x, I get 20y equals 1,800. If I divide by 20, I get 90. Make sure, double check my math on that. On 1,800 divided by 20 is 90. Okay. So I'm going to plot 0, 90 right here. 0, 90. And we'll do the same thing. If y is 0, you get 15x equals 1,800. Let's see that. 1,800 divided by 15 is 120. So you'd sell 120 jeans if you sold no khakis. And that would get you your $1,800. 120, comma, 0. Close that off. Connect the 2 points for all the variations of combinations of jeans and khakis that you could end up selling. Okay. All right, that does it for Unit 3, Lesson 3, graphing in standard form.